In this episode, we will be making this. Welcome back to TI Game Tutorials. As shown before, today we will be working on ASCII Art and Animation. First, we'll be covering ASCII Art, which uses text to make art. Some examples of this are the primitive emojis, the Lenny face, and the also famous uwu. ASCII Art is generally the simplest way to make pictures and faces on your calculator. First, go to Program in the New tab. Then select New and name our program ASCII Art. Make sure you press Enter. And that is our new program. To start the code, as always, go to Program, Input Output, and go down to the Clear Home command that we covered last time. Then press Enter and go to the Display command. Now we'll enter our first piece of art, a little smiley face. Start by, as always, when working with the Display and Output command, going to Alpha Plus, then press Second, Math, and find the equal sign right here. Enter. And then add a closing parenthesis right here, making our little face. Oh, and don't forget to make a quotation mark at the end. Quit to the home screen, Program, and Enter. And there's our face. Pretty primitive, but in the future you can replace this with any other types of faces you want. Now on to animation. For our first example, we will be using the classic bouncing ball animation. Start by creating a new program and naming it Ball Anim. Press Enter. And this is our new program. Now we want the ball to travel from the top left of the screen all the way to the bottom right. Now, from last episode, you might remember that we defined these as 1, 1, and 8, 16 when using the output command. Now, the journey between these two positions is what we really want to figure out with this animation. First, let's find a reference photo for our animation. Now, all we have to do is transfer it to our grid. For the sake of time, I have already done so. And there it is. However, some issues now become very apparent, 3 of which will be the topic of a well-worded email to Texas Instruments ranting about how they discriminate against all animators. First on the list is the limited movement. This 8x16 grid is actually pretty limited. 128 slots is pretty small compared to the limitless possibilities of hand-drawn animators. We can't exactly overlap our animations with each other, which makes our next problem even harder. No squash and stretch. One of the main parts of this animation is to demonstrate squash and stretch, something we simply can't do. Not only with that overlap, but with our limited amount of characters. With just a calculator, you don't really have access to a lowercase o or really anything that has a shape like a flattened ball, or any of the steps in between. This makes our job quite a bit more difficult. This even becomes a problem when speed is involved, seeing as ball shape and their overlap tends to show speed, which is our next issue, with no control over frame rate. TI-84s don't have a built-in wait command, like most other programs, meaning that there's no specific way to say, I want this long to happen between certain frames, which makes it so that our animations will all end up being the same frame rate, which is really fast. The only real way to slow it down is with lag, and that's very hard to do, especially for a calculator that can calculate your gibberish in less than a second. So most of the time we'll be sticking to the built-in frame rate with our program, which kind of sucks. So every ball we see here is a single frame of our animation, meaning that every time we want the ball to progress, we need to show this ball, remove it, show the next ball, remove it, show the next ball, remove it, etc. And you guys can probably already guess which command we will be using. And that, of course, is the ever-present clear home command, which we will be using a lot in this program, along with the output command. For this example, I'm using the top left side of the frame with a simple coordinate of 1, 1. Our ball throughout this will be the classic O, made with the alpha 7 button, and of course the quotes around it, like I showed last episode. For every new output, we'll always have to follow it by a clear home, which will wipe everything above it from the frame. So let's progress through our program. For the sake of time, I'll be displaying all of the output commands we'll need on screen as I fill them out in this following time lapse. Oh, and if you ever miss a space, like I forgot a comma right here, you can just go into second insert and type in the comma. Oh, wrong way. Second insert, comma. There we go. Now, this was pretty messy, and it took me around like 7 minutes. And there we go. There's our ball animation. It's all pretty simple, but it's very repetitive. Now, you can make several different types of edits. You can change the ball shape. You can make it a bouncing 5, I guess. There were some cutbacks I made, like I didn't add a third bounce, and I made the arc a little weird, just to make it work. But you can fiddle around with it as much as you want. If you enjoyed activities like this, be sure to stay tuned for future episodes on programming games for a calculator. Or, animations. Okay, and send. Ah, dang it.